Hi there, grade 9s, and welcome once again to WorksheetCloud Maths. I hope you're all fine this morning. It's a little bit chilly where I'm recording from. I'm in Joburg, and it seems like the cold weather is really here for a while. But I hope you are nice and warm if you're in Joburg and wherever you are in the country. So welcome again, and let's get on with this lesson. Today we are going to start with a new section called Transformation Geometry. So it is our first lesson in this series, and I hope you're going to enjoy it because I love it. But as you know, I just love maths anyway. Okay, so let's start. What is transformation geometry? Okay, transformation geometry is the movement of a shape or a point, and the result of this movement is called an image. And we say what we're doing is we are mapping one image onto another. Okay, so it is the movement of a shape or a point, or we can say a line segment, which is actually a shape, from one point on the Cartesian plane to another. Okay, transformations include translations and reflections, and today we are going to mostly concentrate on translations. We'll actually only concentrate on translations. In the next lesson, we will look at reflections. So make sure you come back for the next one. Okay, so these are known as rigid transformations because the shape and size of the geometric shapes don't change. So the shape and size of the point won't change, the shape and size of the line won't change, the shape and size of the shape won't change. But let's see what I mean. Okay, let's go on. Let's look at how to translate a point. So translations include vertical movements and horizontal movements of points or shapes on a Cartesian plane. So basically around the x and y axis. Okay, so if we have a look at our Cartesian plane, we know that the horizontal axis is the x-axis and the vertical axis is the y-axis. Okay, all comfortable for now. We've done this before. It's not a big deal. We're just looking at the Cartesian plane. Okay, so what we will do is we will look at a point on the Cartesian plane first, and that point is minus 2, 3. So just to go over, remember, we always put in the x value first. So our x value is minus 2 and our y value is 3, and that creates a coordinate for where that point is, which is minus 2, 3, the name of the coordinates. Okay, right, so if we take that point, and we know that it's minus 2, 3, as we were told just now, and we want to translate a 5 units to the right and 4 units down to give the image A1. Okay, so we're going to go 5 units to the right. Here's our A. We're going to go 1, 2, 3, 4, 5 units to the right and 4 down. 1, 2, 3, 4. Okay, and we're going to call the new point A1. Okay, because it has been translated onto a different part of the Cartesian plane. So the coordinates for the image A1 are 3, minus 1. Can you see the x value is 3 and the y value is minus 1, and that shows us the point where that point is. It gives us the coordinates. All right, that sounded all a bit higgledy-piggledy, but I'm sure you do understand. Okay, so that we say that A has been mapped onto A1 by the rule x plus 5, y minus 4. So our original x, y value, where x now we have adding on 5 and y we are minusing 4. So if you have a look, we added on 5 here, 3, 4, 5, and we minus 4 because we're going towards the minuses of y. 1, 2, 3, 4. Okay. So now let's look at how to translate a line segment. Okay, there's our line segment AB, and we're going to translate line segment AB 6 units to the left and 7 units down to give the image A1, B1. Okay, so if we translate this, we're going to have to do each point separately, and then we have to check that the line's gradient is exactly the same in our second image, in the image of AB. Okay, so the first one we're going to do is A. We're going to go 6 units to the left. 1, 2, 3, 4, 5, 6. We haven't finished yet. We're going to now go 7 units down. 1, 2, 3, 4, 5, 6, 7, and that is where our point A1 is going to be. But we now need to do B in exactly the same way. So let's start here with B and go 6 units to the left. 1, 2, 3, 4, 5, 6, and 7 units down. 1, 2, 3, 4, 5, 6, 7. So that should be where our B1 is. But now if we just left it like that, that would mean that we have two individual points and we were translating a line segment. So we need to join those points to make the line segment. And then we can check, is our gradient the same? Yes. Is the distance apart from A to B the same? Yes. So therefore we have translated line segment AB and it has been mapped onto A1, B1 by the rule x minus 6, y minus 7. And we'll go over how to make up that rule later on in today's lesson. But for now, that is the rule that we followed because we went 6 units to the left and 7 units down. Okay, the next thing is let's look at how to translate a shape. So there we have a shape. We've used a triangle this time, and it is triangle ABC. Okay, so now we're going to translate triangle ABC 6 units to the left and 4 units up to give the image triangle A1, B1, C1. Because in each point that we've translated, we have to then name it A1, B1, C1. If we were to take that triangle, the new one that we've translated, and we were to translate it again using the same rule, we would then call it triangle A2, B2, C2. But let's not jump the gun. Let's do this for now. So we've got to go 6 units to the left and 4 units up. We take each point individually and we're going to start with A and we're going to go 6 units to the left. 1, 2, 3, 4, 5, 6, and 4 units up. 1, 2, 3, 4. So our A1 point should be there. Okay, so that is A1. We're going to do the same with B. We're going to go 1, 2, 3, 4, 5, 6, and 4 units up. 1, 2, 3, 4. And there is our B1. And exactly the same with C. So we're going to start here. 1, 2, 3, 4, 5, 6, and 4 units up. 1, 2, 3, 4, and that will be our C1. So we have translated each point individually. We have mapped ABC, triangle ABC, onto triangle A1, B1, C1. Obviously, at the moment, those are just individual points. So what we have to do is we have to join the points to form the triangle. Does it look the same shape and size? Yes, it does, which actually means it has been mapped. The one has been mapped onto the other. So we say that triangle ABC has been mapped onto A1, B1, C1 by the rule x minus 6, y plus 4. Right. So now this is your turn to work. I'd love you to be able to work on squared paper or blocked paper, but if you haven't got that, you've just got a piece of white paper or lined paper, remember to make sure that your intervals on your x and y axis are equal. All right, and you can use your ruler and you can draw your x and y axis in. So what you need to do now is you need to first translate a point according to the instructions that are given there. Then you need to do a line segment, and lastly, you need to translate a shape. So what I'd like you to do now is to pause the video, take down all the information, you work it out on your own Cartesian plane, and when you come back, we will go over it and see how you did. Right, how did you do? Here's our Cartesian plane. The first thing you had to do was to translate a point and plot point L at minus 5, minus 1. So if we look here, it would be minus 5 down here, oopsie, sorry, there, minus 5 down there, and 1 over there, okay? And that would be point L. Okay, what you had to then do to point L, you had to translate it to point L1 and follow the rule x plus 3, y plus 2. So x plus 3, we're going to go 1, 2, 3, because we're moving towards the positives, and y plus 2, we're going to go up, 1, 2. Okay, and so our new point will be there and we will call it L1. Okay, and the new coordinates for L1 will be -2, 1. All right. Okay, the next thing you had to do is you had to translate a line segment. So let's put in our first line, well, our line segment, we've got a plot line segment MN, where point M is 3 minus 1. There we go, X is 3, Y is -1, and point N where it's 1 minus 1. So X again is 1, or sorry, X is 1, but Y again is -1. So it is a straight line, but it is a line segment. All right, now what you had to do is you had to translate line MN to line M1N1, following the rule X minus 4, Y plus 4. Okay, now we've got to first do M, and we're going to go -4, which is going to 1, 2, 3, 4, and then Y plus 4, 1, 2, 3, 4. And that will be where our M1 point is. Okay, we're going to do the same thing for N. So we're going to go 1, 2, 3, 4, 1, 2, 3, 4, and that is where our N1 is. And remember, those two are just points, so we have to join the lines. Okay, does it look exactly the same? The gradient is the same, so yes, one has been mapped onto the other one. MN has been mapped onto M1N1. All right. Now, let's have a look at the shape that you had to translate. So we had to plot, first of all, the square EFGH according to those points. So let's do that first. So E was -2, 2. There we go. And that is our E point. Then F is 1 and 2. There we are. That's F. And then G is 1 and 5. And H is -2 and 5. Okay, again, those are just points until you join the points, and it will make a square. So there we have our square EFGH according to the points that we were given. What did we have to do with that? You had to translate square EFGH onto square E1, F1, G1, H1, following the rule X plus 2, Y minus 3. So we're going to start with E first, and we're going to go X plus 2, 1, 2, Y minus 3, 1, 2, 3. And that is where our E1 is. Now we've got to do F. F is X plus 2, 1, 2, minus 3, 1, 2, 3. And that is where our F1 is going to be. Right, then let's do G. G is plus 2 for the X, 1, 2, and Y is minus 3, 1, 2, 3, and there we go. And then the last one, H, and as you can see, it's going to overlap with our original square, but that's quite fine, okay? So it's 1, 2, we end up on the y-axis, and going 3 down, 1, 2, 3, is going to give us the point H1. Again, those are just points on their own until we join them, and it makes a square. Does the square look like the same size? It is the same size, therefore we have mapped square EFGH onto square E1, F1, G1, H1. Okay, so we have mapped, we have translated a point, we have translated a line segment, and we have translated a shape. We did it together, and you did it on your own, and I'm sure you coped very, very well. Remember, if there's anything you want to ask, please send an email to grade9@worksheetcloud.com and somebody will answer your query. Or you can just go back and watch the video from an earlier point to get a better, or to get the explanation again. Okay, so now let's see how we work out the rule. Okay, here we have a point, and that's point K. And the coordinates for K are 1, 1. As you can see, X is 1, Y is 1, right? And here's another point, and we're going to call that point K1. What are the coordinates for that point? It should be 3, 4. Okay, X is 3, Y is 4. Okay, so now what we need to now do is we need to subtract the like coordinates for K from the coordinates for K1. And when I say like coordinates, I'm saying the x values we must subtract from the one point to the other point, and the y values we must subtract from one point to the other point. Okay, so what we're going to do is we got x in K1 minus x in K. So we're always going to go from the second point to see how it moved, what the difference was. All right, so the x in K1, as you can see here, is 3, and you can see here is 3, minus the x in K, which as you can see there is 1, and there on the Cartesian plane it is 1. So 3 minus 1 is 2, and it is a positive 2. Okay, and then you're going to do the same with the y values. So you're going to look at K1, and the y value in K1 is 4, and the y value in K is 1. So it's 4 minus 1, and that's going to give me 3. Okay, again, it's a positive 3. So our rule will then be x plus 2, y plus 3. And let's see, let's go from the original, x plus 2, 1, 2, y plus 3, 1, 2, 3. The rule works. All right, so that's how you work out the rule. But let's carry on and try it again. Okay, here is our k value, and again the k value stays the same. It's 1, 1. That's the coordinates for k. Now we've moved k and we've put it down there, and that's k1. Okay, we haven't followed the same rule. We are now going to work out the new rule for where the new movement is. Okay, so we're going to go coordinates for K1 are 3 minus 2. As you can see, 3 minus 2. And we need that to actually help us work out the rule. Right, so we're going to subtract like coordinates from K of K from the coordinates for K1. So we first are going to look at the x coordinates in K1 minus the x coordinates in K. And the x coordinate in K1 is 3. Here we go, there it is, it's 3, and the x coordinate in K is 1, and there we have it there. So it will be 3 minus 1, which will give me 2. Now for the y coordinates in K1 will be minus 2. There we can see the y coordinate is minus 2, and here it is 1. So we're going to go minus 2 minus 1 is equal to minus 3. So what is the rule? The rule is x plus 2, y minus 3. And the reason we write it like this, as I said earlier, there's your original x and your original y, and it is moving to x plus 2 and y minus 3. Wherever x and y were, they're going to move x plus 2, y minus 3. Let's see if it works. Okay, here's our original. We're going to go plus 2, 1, 2, and we're going to go minus 3, 1, 2, 3. Remember, plus, we're going further up on the positive side of x, and here we are going towards the negatives of y, and that's why it is a minus y. Right, so let's do it again. Here is our k once more, and the coordinates have stayed the same. Let's look at a new position for k, and that's k1. Right, and the coordinates for k1 are minus 1, minus 3. Can you see that both coordinates for K1 are now minus? In our first one that we did, when we moved the point, here it was plus, plus, here it was plus, minus, now it's minus, minus. So I just wanted to give you an example from each one. Okay, so now we subtract like coordinates for K from the coordinates for K1. And I'm going to go x in K1 is minus 1, minus x in k, which is also minus 1. So minus 1 is minus 2. Let's do the same for y. We're going to go y in k1 minus y in k, which is minus 3 minus 1. It gives me minus 4. So the rule is, from the original xy, we have moved x minus 2, y minus 4. Let's see. Here's our original, minus 2, 1, 2, minus 4, 1, 2, 3, 4. It works, so the rule is correct. Okay, you try. Here we go, there's 1 point, and that's H, and there's another point, and that's H1. I want you to try and work out the rule just as we've done it before. So I want you to pause the video and you work out the rule, and then when we come back, we'll go over what you've done. Right, let's see how you did. Here's the Cartesian plane. We were given our two values. There's h where it's 3, 2, and h1 where it is minus 4, 4. Okay, what do you do to work out the rule? We're going to subtract the like coordinates for h from the coordinates for h1. So the first thing we'll do is we'll do x in h1 minus x in h. Okay, x in h1 is minus 4, and we're going to minus 3 from the minus 4, and we're going to get minus 7. So straight away we can say, if I move it to the left 7 places, is that correct? 1, 2, 3, 4, 5, 6, 7. Right, that is correct so far. Right, let's do the y value. Y in h1 is 4, and we are going to subtract 2 because the y in h is 2. Okay, so 4 minus 2, we're going to get 2, and here we've got, well, we ended up there, so 1, 2, or we can go from here 1, 2, and there it's on that line. So our rule is, from our original xy, we're going to go x minus 7, y plus 2. Can you see the minus 7 there? So that forms minus 7 plus 2, that forms the plus 2. Okay, so actually x's, we're going towards the negative, and y, we're going more into the positives. Okay, right, let's have a look here. We've now got shapes. We're going to look at how to work out our rule for a shape. So we're going to start here with point P, and then do point Q and point R, and as you can figure it out, we've got a triangle. So now we're going to translate that triangle, and we've got point P1, point Q1, and point R1. Let's just name them, and we will join them up, and we can see that they look exactly the same. They are just in different positions on the Cartesian plane. So we now have to work out what the rule is to get from PQR to P1Q1R1. Okay, so what we can do to work out the rule is we take any point. So we're going to choose one point here, and we're going to use point P. So we're going to look at P, and we're going to look at P1. The coordinates for P are 4 and 3. Can you see 4 and 3? And the coordinates for P1 are minus 2 and minus 4. And we're going to do exactly what we've done previously. We're going to subtract the like coordinates for K from, sorry, it's not K, from P and P1. Let me just fix that for us so that we don't get confused. I fixed that for us. So we're going to subtract the like coordinates for P from the coordinates for P1. And we've got the coordinates written up here. Okay, and we're going to go x in P1 is minus 2. There you can see there, and you can see it here. It's minus 2. And we're going to subtract that, we're going to subtract the x in P from that. So what is the x in P? The x in P is 4. So it's minus 2 minus 4 is going to give me minus 6. And then we're going to do the same for our y values. So our y values in P1 is going to be minus 2. That's incorrect as well. Fix that for us as well. So the y value in P1 is minus 4. And the y value in P is minus 3, or is 3. So we're going to go minus 4 minus 3 is minus 7. So therefore, our rule is from our original x, y points, x minus 6, y minus 7. Let's check that, okay? And let's check it using another point. So if we've got our R point, we're going to go down to our R1. So we're going to go minus 6, 1, 2, 3, 4, 5, 6, and then we're going to go minus 7, 1, 2, 3, 4, 5, 6, 7. It's absolutely correct. It works for 2 of the points. It will work for the third one. If you wanted to, you could check the third point. So let's check it. We're going to go Q minus 6, 1, 2, 3, 4, 5, 6. Q minus 7 on the y-axis. Then we're going to, we're going to go 1, 2, 3, 4, 5, 6, 7. So our rule is correct. So what you would do with a shape, is you would work out the difference in one of the points from the original point to one of the other points, and then check it on the other points in the shape. So if that makes no sense, let's just go over it again here. We worked it out for point P to point P1. Once we had done that, we can then check it on point R to R1 or Q to Q1. And if that rule is applies, then the rule is correct. If the rule doesn't apply to the other points, then possibly go back and check where you may have made a mistake. Okay, guys, so that was translations, and I know that you are quite happy with those. I know that you've picked them up quite well. If you are having any worries about them, please don't forget to email through to grade9@worksheetcloud.com, or watch the video from the beginning and pause it and work it each time on your own and see if you can basically translate it into your own language to make sure that you understand it. Because the biggest thing here is understanding. Once you understand the rule and how to work out the rule and how to apply the rule, then all is well and good. Okay, when I see you again, we're going to come back and we're going to work out the reflection part of it. So thank you so much for watching today's lesson. I'm sorry about the few mistakes that happened, but I'm sure you can pick it all up. Right, see you next time, guys. Keep well and keep warm.